Hello and welcome back to this amazing channel. This is Abhinav. In this particular video, we will discuss about the contest Codeforces Round 937. This is a Div 4 contest, right? But the problems of this contest were really good, and we will discuss about the first 6 problems of this contest, right? This is from A to F. Let's discuss all the problems one by one. Also, before starting, let me tell you guys about the newbie to expert CPC that we have launched right recently. So this CPC that we have launched, uh, I told about this seat previously. Currently, I have added 150 questions in this particular seat, but we are planning to add around 170 questions in this seat. So that also we will, add soon. I will provide a link for this seat in the description, right? You can check out from there. You can start practicing this seat. Each question of the seat contains the code link and the video tutorial of this particular problem, right? Cool. Amazing. So let's move forward and talk about this. So let's talk about the first problem, which is the stair, peak, or neither. So this is a very easy problem, as you know, the first problem of division 4. The problem was that there are 3 numbers given to you, A, B, and C. Okay, and you have to actually check if there's a stair, peak, or nothing. Okay, what is stair? If A is less than B and B is less than C, then it's a stair. If A is less than B but B is greater than C, it's a peak. Else it's none. Right. So that is what it is given to us. So now what and how we will do this? So what we basically do here is, guys, if you will see my solution code here, I have done very simple basic thing that uh, if A is less than B and B is less than C, the first condition, simply stair. If A is less than B, B is greater than C, it's peak, and else none. Simple if else is there, right? Amazing. Next comes is the problem number B, which is upscaling. This problem was actually a complete implementation based problem where you have to just implement the thing that they are wanting. So they're basically saying you that you are given an integer n and you have to print the 2n by 2n checkboard. Basically, you want to create that checkboard by by hash and dot in this manner. So a block of 4 hashes, then 4 dots, and so on is there, right? So how we can do it basically, guys? So if you will see, this checkboard is of size 2n into 2n. How I have implemented this pattern is, if you will see here, how I have implemented it is, so taken here. Okay, I'm taking for each row from 0 to where I'm going, and because when there are n rows, we have to print 2n rows, like 2n. So I'm printing the same thing twice. You can see, because if you will see, same row is printed twice. For example, if I will get each pattern here, I hope it should get download. Sometimes it takes a lot of time. Wait, it should get downloaded. Cool. So if you will see here, this image, every row is repeated twice. So for example, this first row is repeated again. So the same thing is again printed. Similarly, this row is again printed. This row is again printed. So each row is printed twice. So whenever I am printing a row, if you will see in my solution, I am doing the same thing 2 times. I am printing the same row 2 times. But how the elements of the row are printed? In case of elements also, you can see, guys, that each symbol is repeated. So if you will see just this row, okay, hash is printed 2 times, then dot is printed 2 times, then hash is printed 2 times, and so on. So hash dot 2 times are printed. But how are they printed? So if you will see guys, if you will take the number of rows as I and this as j, so when I plus j is even, you will see that hash is printed. And when I plus j is odd, a dot is printed. That is what I have done. That is what I have done. So if you will see here this is the, let's say, the zeroth row, zeroth column. So 0 plus 0 is even. This is a dot. Now this is the first column. 0 plus 1 is odd. Dot. Then hash. Here it's the first row 0 column. So dot. So this is how it's printed. So if you will see what I've done, if I plus j is a even, hash 2 times, else dot 2 times. Right? So this is how I'm doing this particular thing and printing this pattern. This was a completely implementation based problem, right? Amazing. Let's move to the next problem then. Next is this clock conversion problem. This was again a good problem. Basically again an implementation based problem where you have to just simply implement how you can print this particular thing. So you have to convert a 24-hour clock into a 12-hour clock. Let me tell you how I've done this. Actually, I firstly had submitted a very wrong submission, having wrong answer on test 1 even, right? But yeah, now this is how I am getting. So if you will see here what I've done, I have first of all taken my x as am. Am means okay, I'm assuming it's am. Now I'm first of all from the string, I'm extracting the hours and minutes from it. Okay, so this is the number of hours and number of minutes. For example, if your string is something like this, let's say 14, 39, like this. So I will first take this thing as r. So this is 0, 1, 2, 3, 4. So r is 14 and minute is 39. So you can see I am taking the 0th character and first character and third and fourth as a 2-digit number, right? Now if ours is greater than equal to 12, if ours is greater than equal to 12, what we will do is we will subtract hours by 12 and we will make it PM. Means it was more than equal to 12, that means it's a PM time. So I made x is equal to PM and separated by 12. Also in a 24 hours format, hours cannot be 0. You cannot say 0039 PM or you cannot say 0039 AM. 0 is only always taken as 12. 12:39 PM, 12:39 AM. So whenever r is 0, I am making it 12. Now guys, time to print it. While printing, like for example here, if you will see your r is 12. Because it is more than 12, it is 14. Because it is more than 12, it will become 2. But you will not simply print like this. You can't. You have to add a 0 here, extra 0. So I'm saying if my r is less than 10, means it's a single digit number, I print the extra 0. Similarly for minute, print the extra 0. And then finally x, whatever AM or PM it is, right? So this is how I have written this particular code, right? Amazing. So next one is the problem product of binary decimals. This was also a really good problem. So the problem was that you are given a number and you have to find whether that number can be presented as the multiplication of some binary decimals. So what are these binary decimal? Binary decimal are those decimal numbers. So they are not the binary numbers. They are the decimal numbers which are just present with 0 and 1. For example, if I will write the whole array of binary decimal numbers, it will start from 1, then 1 0 1 1, means basically 1 10 11, then 100, then 110, then 100, then 101, then 110, then 111, then 1000, right? Then 1001, then 1010, then 1011, and so on. These all are binary decimal, right? So you have to basically find that the given number n, can we present this given number n as the product of binary decimal number? So guys, we will do this problem in a very brute force manner. So first of all, we will get an array which contains all the binary decimal numbers, right? So how we can do this thing actually? So see guys, if you will see, we will not consider 1 because obviously every number is divisible by 1. We will start from 10 and 11. So these two numbers 10 and 11 will be the first two binary decimal numbers. Now guys, if you will need the next binary decimal number, how you will find? What you will do, in the same number 10, you will first multiply at 10, that will add an extra 0 here. So 10 into 10 will be 100, and then add 1 here. Now same for this, multiply 10, then add 1. Then for this, multiply 10. So one by one, I first did this for this, then I got these two numbers. Then I did here, I got these two numbers. Then I will do it here, I will get plus 1, these two numbers. So from the previous binary decimal numbers, I can create new binary decimals later. And this I will go until they are less than equal to n. Because we don't want numbers which are more than n. We want it to be divisible by n. Right? That's the first thing. So what I am doing here is, if you will see, I am first of all creating such numbers. By the way, I can do this thing in like pre-calculate also, but I do it for every test case. I am doing it. So initially in this vector, what I am doing is, I am adding 10 and 11, which are the first two binary decimals. Now I am starting from I is equal to 0. For example, let me explain you in a good way. So initially I have taken my V with 10 and 11, right? With indexing like this, and I is at 0. So when I is at 0, what I am doing is, I am first creating a X and a Y. So what is X? X is this Vi into 10, and Y is X plus 11, X plus 1. So now this 100 and 101 is also added. Now I moved forward. Now for this 10, now for this 11, do the same thing. What? 11 into 10 and then plus 1. Right? Now again move forward. Again move forward. So now it will be, this is I, right? So 1000 and then 1001, then add it. This we will do until the value is less than equal to n. So you can see for each I am getting, if x is less than equal to 1 and y is less than equal to 1, x is vi into 10 and y is x plus 1, means usi mein 1 plus 1. And when this I will go out of the range, for example, you did for everything, I came here, and now all the numbers are greater than n, you will stop. Okay, so now you have the array that contains all the decimal binary decimal numbers which are less than equal to n. Now we will sort it in a reverse manner. So they are already sorted actually. If you will see, you will find the thing in this way, they will be already sorted. Now we will do it in a reverse manner, right? Because we will first try to divide your number n with the greatest decimal possible, right? You will reverse it. Now until your n is 1, while your n is greater than 1, you will try dividing n by the numbers of this binary decimal. So while n is greater than 1, you will iterate through all the binary decimal numbers. You will try to divide n by that number. If n is divisible by that number, you will divide it and then move forward for the next division. But if in any case, अगर n किसी भी numbers divisible नहीं है, for example, if OK is false, and for any number n is not divisible with any of the binary decimal numbers, that means OK will become true, and if OK is not true, we will break कि जो n है वो किसी भी नंबर से डिविजिबल नहीं हो रहा है. And at the last, if n is not 1, that means yes. Oh sorry, if n is 1 means yes, it is possible to get it by multiplying some decimals because it is divisible by them, else no, right? So this is how we are doing here. So we are trying to divide that n by different binary decimals as possible. And if we are getting a finally 1, that means it's possible to also represent n as a multiplication of them, right? Because if a number is divisible by something, it can be presented as multiplication of something, right? Cool. Now the last two problems, and before moving on to this problem number E, guys, let me tell about that CP newbie to expert CP seat, right? That I have discussed in the previous video also. So we have launched this CP seat in our coding75.com website, and we have currently added around 150 problems in this site. But guys, we are actually adding more problems, and there will be around 175 problems that we will add in this particular sheet, and we'll keep it updating with some new good problems that we feel are important for the sheet, right? So you guys can start practicing this sheet. We have introduced some features like you can save the status of the problem for a particular sheet. If you have solved a problem, you can just save it to solve. You can filter the solved problems, the trying problems, right? You can also sort it by difficulty level from 8,000 to 1,800 to 1,000 and different difficulties, right? This is how you can solve the CP sheet with the full screen mode. Just focus on solve. Each question has the code link, the video link, and all of that. So you guys can actually, visit this CP sheet, check this out, okay, and start solving CP questions, right? You can also make a problem bookmark, remove it from bookmark, and all of that you can do using this, right? Amazing. So now let's move forward to the problem number E. This problem number E is also a very interesting problem, which is a nearly shortest repeating substring. So the problem actually is, guys, that you are given a string S, right? You are given a string S. Now you have to find a string K. What is string? String K. Such that if you will add this string S multiple times, right? Such that its length is same as length of S, and the characters of this string K should also be equal to the character of string S, but they can differ at most one position. For example, अगर आपका S है, for example if S is FAH FEH, right? तो इस केस में क्या कर सकते हो, you can take your K as FAH. When you will take your K as FAH, you can add it 3 times so that it will finally become like this. And you can see it is completely similar to S instead of only one character, which is this E. So one character can be different. And even it's possible that no character is different, the complete string is fine. So if this is the case is happening, that means you can get your, means that is the string of K that you can get. Now you have to find the shortest possible string K that you can get, and you have to print the size of that K. Right? So shortest possible will be 1 only, and it can go up to max to n, right? So how I have actually did this problem, guys, actually I took help for the last 2 problems actually, because I was not giving this contest in my, actually it's a festival season, right? And I'm currently in my home, so I'm not giving these contests seriously, because obviously it was a day 4 contest, I was out of competition. But okay, I just solved this problem just for you guys to make a video, right? Cool. So guys, first of all, if you will see one thing, if you want to have a string K, okay, and you will repeat this string K such that the final concatenate product size is equal to the size of S. That means this K should be a divisor of S. For example, अगर S का size है 15 and K size is 4, you can never make 4 plus 4 plus 4 equal to 15. Never. So this case, the size of K should always be a divisor of S. That's the first thing. So first of all, what I'm doing here, guys, is that I am taking length n and string S, and I'm getting all the divisors of number n. So using a function getDiv, I'm finding all the divisors of number n. You can see here. This is a simple way of divisors, and I'm sorting the divisors also, because now later we want sorted numbers, right? We are sorting divisors. So this I'm doing for every test case, and after each test case I'm clearing the divisor wala array, right? Amazing. And here I've written a function check string boolean function. This is actually checking that for a string A and a string B, at how many indexes it is differing. So if it is differing at an index, I'm increasing the value of C. And as I told you, that the string that will be created using K and the original string S, they should not differ for more than 1 times. If they are differing for more than 1 times, I'm returning false, else I'm returning true. So these both the functions I will use in my main function A square, right? So what I've done here, so first of all, for the number n, I'm finding all its divisors. So using the getDiv function, all its divisor will be stored in the divisor vector, right? Now I'm iterating to all the divisors of a number, because we will check for all the case. For example, कि इस केस में यहाँ पर हम एक साइज के लिए भी देखेंगे, 2 के लिए भी देखेंगे, 3 के लिए भी देखेंगे, जितना भी पॉसिबल है. For all the divisors of this S, we will check that whether for that divisor is it possible or not, right? For example, current divisor is IT. ठीक है, मतलब अगर हम IT लेंथ का एक K स्ट्रिंग लें और उसको रिपीट करें such that the total size is equal to S, तो क्या वो दोनों मैच कर रहे हैं, क्या वो पॉसिबल है? तो हाउ आई एम चेकिंग? तो फर्स्ट ऑफ ऑल आई नीड आई स्ट्रिंग ऑफ आई टी। फॉर एग्जाम्पल यहाँ पर ये सेम हम ले लेते हैं, यहाँ पास एफ ए एच और एफ ए एच था, ऐसे था एफ ए एच एफ ए एच एफ ए एच। सो व्हेन आई टी विल बी वन, वन के लिए पॉसिबल नहीं है, बिकॉज अगर आप वन लोगे, एफ की बनाओगे या ए की बनाओगे तो पॉसिबल नहीं है, राइट? इट्स नॉट पॉसिबल. When it will be 3, it's possible. How? You will take this as your k, right? You will repeat it 3 times. यहाँ पे अगर एक e भी आ गया तो एक जगह डिफरेंस हो सकता है. That is what I am saying. मैं स्टार्टिंग की सवेरे ले रहा हूँ IT साइज की, उसको रिपीट कर रहा हूँ n by IT टाइम्स टू मेक इट इक्वल टू द सेम साइज ऑफ s. नाउ आई एम चेकिंग कि क्या पॉसिबल है temp और s में कि सिर्फ एक चेंज हो. बट इफ यू विल सी, आई एम ऑल्सो टेकिंग सम k2 एंड temp2. ये केस कब आएगा? दिस केस विल कम, फॉर एग्जाम्पल यहाँ पे एफ ई एच पहले है, तो के वन क्या लेगा? केवल विल टेक एफ ई एच एंड एफ ई एच. इस केस में क्या, दो बार जो दो जगह चेंज आ गया, ई और ई. बट स्टिल आंसर इज पॉसिबल. योर प्रीवियस केस विल रेस नो. अगर आप लास्ट का भी बार देख लो तो एफ ए एच, क्योंकि ये जो ई ए कहीं ना कहीं होगा, या तो पहले होगा, लास्ट में होगा, बीच में होगा, दोनों में तो नहीं हो सकता. तो फॉर टेकिंग दैट कॉर्नर केस आई एम टेकिंग बोथ, starting substring of size it and end substring of size it also, right? And then I'm creating temp and temp2. If any one of the temp and temp2 is possible, I'm printing it, that okay, for this it there is a possibility, okay? Else हमेशा n के लिए पॉसिबल होगा ही, n is always a divisor, तो n तो हमेशा पॉसिबल होगा ही, तो n हमारा आंसर हो जाएगा, whatever is the answer, right? So guys, this is how I am solving this particular problem, which is this nearly shortest repeating substring. Now guys, this next problem 0, 1, 2, 3, this is also a very interesting problem, and if you will see the code for this problem, this is also very great, right? So first of all guys, the problem says that you have 3 numbers a, b and c. Now you have to create a tree of a plus b plus c vertices, right? You have to create a tree, and the condition is that a are number of nodes that has 2 children, b are number of nodes that has 3 children, and c are number of nodes that, oh sorry, not 3 children, that has 1 children, and c are number of nodes that has 0 children or 0 childs, right? अब देखो, is there possible to create a tree such that this is also taken, a nodes हो exactly a nodes जिनके 2 children हो, exactly b node with 1 children, exactly c node with 0 children, and total we need a plus b plus c node. Is it possible or not? Right? So how we are solving this particular problem? Let me explain you with the code simultaneously, right? Then you will get it more clearly. See guys, first of all, I have taken a multiset. Multiset basically is a data structure that stores numbers in a sorted manner. Okay, not in a unique way. It's a multiset. So there can be multiple numbers, but in a sorted manner. Okay. Now for number of C's means number of number of nodes which has 0 childs, there are C. So C number of times I am adding 0 in this ST array. Basically this will represent कि okay, इतने childs है हमारे पास और basically इतने nodes है हमारे पास जिसके 0 childs हैं. So I'm adding C number 0 here in this ST. That will represent that okay, I have this much number of nodes which has 0 childs. Okay, now what I'm doing? Now I want B number of nodes with 1 children. Up see guys, this is a very important thing. It's a very important thing. For example, if you have 3 children with 0 childs, let's say C is 3. So let's say, so those children with 0 childs will obviously leave nodes, so they must be present at the last. Let's say ये वो 3 nodes हैं जिनके 0 childs हैं, they don't have any childs, right? Now we want B nodes with only 1 child. So what we can do, we can add that B nodes just above this. Just above this, am I right? तो वो B node इसके just ऊपर लगा सकते हैं, just above this. Okay, this is here, this is here, this is here, just above it. Are you getting or not? So these are of 0 size. These are of size 0. Okay, initially we have all the nodes here, and we want B nodes which have only one child, right? तो उसको से जस्ट ऊपर लगा सकते हैं, just above this. Then more, I want more, okay, just make it above this, right? तो यहां तक की हाइट 0 थी, यहाँ हाइट हो गई 1, यहाँ हाइट हो गई 2, तो हाइट इज गेटिंग इंक्रीज्ड. तो ये जो मल्टी सेटर है इसमें हम लोग हाइट ही स्टोर कर रहे हैं बेसिकली. तो इनिशियली हाइट इज 0, आई एम एज्यूमिंग दिस इज द हाइट 0. So initially I have made all the 0 heights because these leaf nodes are at height 0, right? Now what I'm doing is for B's, अब जो B होंगी means the node which has one child, they must be present at the top of the nodes having 0 child. तो वहां पे एक हाइट बढ़ गई. What I'm doing is देखो, अगर ST empty मतलब ये कोई भी ऐसा नोड है ही नहीं जिसमें 0 चाइल्ड है, मतलब कोई भी नोड बचा ही नहीं 0 वाले, बिकॉज 0 वाला ना जरूरी है. अगर एक भी 0 वाला नोड आ गया जिसमें 0 चाइल्ड है, because nodes with 0 child should always be there. There should always be leaf nodes. अगर 0 child कोई नोड ही नहीं है, C अगर 0 है तो आंसर पॉसिबल ही नहीं है, राइट? आंसर इज नॉट पॉसिबल. आर यू गेटिंग? तो what we will do, we will add these B's at the top of the nodes which have 0 childs. Are you getting? So what I'm doing is I'm first of all getting, अगर ST 0 है मतलब ST is empty, that means there is no childs remaining, print -1. Else what I am doing, else I am first taking the beginning of the ST. कि बिगिन ऑफ द ST क्या है? इट कैन बी 0 ऑल्सो, इट कैन बी 1 ऑल्सो, बोथ पॉसिबल. फॉर एग्जाम्पल कि आपके C3 था, ठीक है, तो जब C3 है, वी हैव एडेड 3 times 0 in our ST. So in our ST 3 times 0 is added. So first time what will happen, you will take a 0 from ST beginning, you will erase it and you will add 0 plus 1 in the ST, meaning एक 0 आपने हटा दिया, यहाँ पे आपने एक नोड ऐड कर दी, एंड आपने बिकॉज एक नोड ऐड हो गई, ये अब लेवल हो गया 1, यहाँ पे आपने एक 1 यहाँ पे ऐड कर दिया. नाउ इट बिकेम 0, 0, 1 इन सॉर्टेड. नाउ लेट्स से B इज लेट्स से 4, तो आपने एक और निकाला, एक और 1 यहाँ पे ऐड कर लिया, तो नाउ इट बिकेम 0, 1, 1. ये 0 बचा है, ये दोनों 1, 1 हो गए, इनकी हाइट 1 हो गई, राइट? नाउ सिमिलरली अब इस 0 को बैठाया, एक और 1 आ गया, बट B4 है, एक और चाहिए, तो इसको हटाया और 1 + 1 2 ऐड हो गया, बिकॉज एक यहाँ पे और लग गया. अब देखो, यू हैव 3 नोड विद 0 चाइल्ड्स, 1 2 3, एंड यू हैव 4 नोड्स विद 1 चाइल्ड, 1 2 3 4. सो मीन्स C and B आर डन. नाउ कम्स फॉर A. A कैसे करेंगे? नाउ वी नीड A नोड्स हैविंग 2 चाइल्ड्स. तो सिंपल है, अभी जितने हमारे चाइल्ड्स हैं, we will add a node and connect them. Simple. Add a node and connect them. तो पहले तो see, because we need now a node having 2 childs, so there should be at least 2 nodes in your ST to connect them. तो मान लो अगर आपका A1 है, then what you will do is you will take the beginning. देखो एक beginning मान लो 1 है, मतलब एक यहाँ पे आ सकता है, एक यहाँ पे आ सकता है, दोनों चले गए, राइट? एंड x + 1 हमने क्या किया, 1 + 1 यहाँ पे 2 ऐड कर दिया, मतलब ये नोड भी देखो सेकंड हाइट पे है और ये नोड भी सेकंड हाइट पे, 2 नोड है, ठीक है. अब अगर एक और होता, मान लो हमारे a की वैल्यू अगर 2 होती, इफ a वैल्यू इज 2, देन वी कैन ऐड 1 more node. This 2 will also go, it will connect and height will become 3. Last में in this ST only one element should be there. If there are more than one element, that means the tree is disconnected. More than one nodes are there, it's not possible. अगर लास्ट में ST की साइज 1 है, तो just print that size. That's the answer. Else -1. If you will see, अगर हम पहले देखें, there was 2 2s present, तो आंसर इज नॉट पॉसिबल. मीन सिर्फ एक 2 नोड से आंसर पॉसिबल नहीं है. हाँ, when I make A is equal to, I can take one more node. Now answer was possible with value 3. ये मिनिमम हाइट कितनी आ रही है? 3 आ रही है. So we have to print the minimum height actually at the last. If you will see, the question was you have to print minimum height of such a tree that we can get. Right. So guys, this is how we are solving it. We are first getting okay how many zeros we can take. Then on the top of zeros we will get nodes with 1 child. Then out of that 1 we will be taking nodes with 2 childs. And then checking at the last if we have only a single root node with a particular height or not. Because at the top there should be a root node. Right. So guys, that's the problem, and this is how we have solved it. So I hope that you have got the good understanding of all the problems. And also guys, do check out this a new video expert CP seed, And also check out the other features of our coding75.com site. For example, a dashboard. We have multiple things. We have resume builder. We have projects, CS fundamental, internships, a lot of things, and also our Coding 75 Pro that we are launching soon. So cool guys, thanks a lot for this particular video. I hope that you got the complete understanding. If you have any doubt, please do comment your doubt. You can join our Telegram to ask your doubt. Please like the video, comment on the video, comment helpful, subscribe channel, share the video if you liked it. Thank you.